Okay, here this problem says a person is standing 350 feet away from the model rocket that is fired straight up into the air at a rate of 15 feet per second. At what rate is the distance between the person and the rocket increasing? Okay, so first of all, it's best if we draw a picture. So the picture we're going to draw is a triangle. This arrow here is going to indicate the rocket, and this is going to become the distance from the person and the rocket. Okay, so this is the distance, and so we'll draw somebody here. So that person's standing 350 feet away from where the rocket, okay, before it's fired. Okay, then it's going to be fired straight up, and so the rocket is actually right here, and it's traveling upward at a rate of 15 feet per second. So I'm going to write that there. Now, they want to know the distance between the person and the rocket, the rate of which it increases, okay, because the farther the rocket goes up, the distance from the rocket and the person is going to increase. But we want to know the rate of that. So we're going to use a formula that is visual to us here, which is c squared is equal to a squared plus b squared. Okay, so we're going to write c squared is equal to a squared plus b squared. And actually, we're going to use that formula to find out what that length is, but that's not going to be our answer. Our answer is going to be the rate, and we'll talk about that right now. Looking at this, the formula, we need to assign the c, we already assigned it to the hypotenuse. A and B needs to be assigned to the legs. So we're going to go ahead and call A this side here. So A is equal to 350. Okay, B, on the other hand, well, at this point we don't know. But we can figure it out. We have enough information for the first part of the problem. Okay, and we'll talk about that right now. But right now, let me talk about this equation here. This equation is a Pythagorean theorem, but it's the equation that brings everything that we're talking about here together. Okay, all these variables here only describe length. They don't which are single units. They don't describe the rate. But what have we been learning? We've been learning that the derivative is the rate. So knowing that implicit differentiation, we can go ahead and find the derivative for all these three variables. Now, this time we're not going to find the derivative of x. There's no x there in the equation. So it's actually in respect to seconds, which is in respect to time. So it's not x anymore. So that's why implicit differentiation is important to understand. So I'm going to go ahead and take the derivative of c squared, which is going to be 2c, and then we put c prime. That's going to equal to 2a prime plus 2b prime. Okay, this is the implicit differentiation of this formula here. This describes units, which is length. This one describes length and rates. Okay, so now let's try to see if we can figure out what the values are. Here it says 20 seconds after the liftoff. So that means after 20 seconds, if I multiply 20 seconds times 15, right, I'm going to find out that B is equal to what? It's going to equal to 20 times 15, which is 300. So right now I can find out what C is, and we're probably going to be able to use that to help me solve for the equation that we need. So we're trying to get as much information that we can. So we're going to go 350 squared plus 300 squared. Together that's going to be 350 squared is 122500, and then 300 squared is going to be 90,000. Okay, after you figure out what C squared is, you're going to find out that after you take the square root of both of them, you're going to find out that your C is 460.98. Okay, so that's the length of this one, and actually it's all this is in terms of feet. So this one's feet, this one's feet, this one's feet. So that's going to be 460.98 feet. Okay, so I'm trying to find at what rate is the distance between the person and the rocket. So I'm actually not trying to find this one. I'm trying to find C prime. This is the actual rate between person and rocket. Okay, this is B, which is the length of 300. B prime is the distance between, or the rate between the liftoff point, which is a platform where it ignited, and where it's currently at vertically. So that's not what they're asking for. They're asking for C prime. So let's go ahead and see what they're going to do here. Actually, B prime is actually the rate of it. So the rate of the rocket is how this is changing the distance from the starting point to wherever it's at. So that right there is my B prime. So now I'm going to plug that in there. I'm going to plug in 300 in here. Okay, and that's what I'm going to do here. So I can be able to solve for what I need to. So here in this area here, I'm going to do 2 times C. C is what? 460.98. C prime is what I'm looking for. And then 2 times A. A is 350. And A prime, well, A prime is never going to be moving because he's just looking at the rocket as it goes up. So the rate of this length is actually 0, okay? And then 2B is 2 times 300, and I had talked about that. And B prime is the rate of the rocket going vertically. So that's going to be 15 there, okay? So now all I do is do some algebra there, and I'm going to do 460.98 times 2. That's going to give me 921.96 C prime. This is going to give me 0, and 2 times 300 times 15 is going to give me 9,000. So to find C prime, all I have to do is divide 9,000 by 921.96. And that's going to be 9.76. What does that mean? C prime is 9.76 feet per second, feet per second, um, that this link is changing from whenever the rocket is climbing. That's how far it's actually the difference of, and that's the rate how much it's changing. Okay, yeah, the distance right now is 460.98 feet, but it's going to be changing at a certain rate as this climbs, and this is the rate that we're looking for. Now, what I want you to try is I want you to try to solve for B, and it's 1 minute. The one thing that I need to make you aware of is all you have to do is convert it to seconds, and then use it the same way that I've used 20 seconds to figure out my answer for B.